In this video, we're going to consider how you solve a quadratic inequation, which is a quadratic expression. Instead of being equal to 0, it's greater than or less than 0. It's a similar technique in some ways to solving a quadratic equation, but it also differs in some ways. So it starts off in the same way, in the sense that you're going to take this expression and factorize it, but you've got to be careful not to try and mimic a quadratic equation too closely. So the first thing is, like a quadratic equation, the terms have got to be on one side and it has to be a 0 on the other, regardless of whether it's less than or greater than 0, but all the terms have to be on one side. If one of these terms was on the other side, just like a quadratic equation, you've got to bring those terms all to the same side. So this is set up ready to go. It's in the correct format. We're going to factorize this. It's a trinomial in this case, so it's going to factorize into two brackets. This would also work if it was a binomial. You could just factorize into one bracket. For example, if there was no 9 there, you could use a common factor of x. So in this case, it will factorize as an x, a 9 and a 1, and we need two negatives. In the case of a quadratic equation, let's say that we had now x minus 9, x minus 1 equals 0. In this case, we would separate that off into two little mini equations, x minus 9 equals 0, x minus 1 equals 0, and we'd solve those to get 9 and 1. The 9 and the 1 that we've solved for, they're the solutions to the equation, but they're also the roots of the graph. So this is what we do in the equation case. The thing that most students want to do in this case is to mimic this. So let me show you here what not to do, but what most students do. Most students will say, okay, well, I'm just going to take x minus 9, and like this part here, I'm going to make its own little equation or inequation, but I'm going to set it greater than 0 because it's greater than. And I'm also going to take x minus 1 and make that greater than. Now, why is that a problem? Well, it's a problem because we've got two things multiplying here. A bracket and a bracket means multiply. We're saying we're multiplying two things together to give you a result which is greater than 0. In other words, a positive. But when you multiply two things to get a positive, either they're both positive, like this, or they're both negative. We don't know which one's which, and we can't tell by the algebra which one's which. So we don't do it like this. So this is the thing to avoid. What we do instead, we do a little bit of side working like this to get the actual root points. Or sometimes usually you can just tell what the root points are going to be, so 1 and 9, just by flipping the signs. And we're going to use these two root points to sketch a graph of the parabola. Remember, this is a quadratic function, so it would make a parabolic shaped graph. So we just take a little sketch, doesn't have to be too fancy, roughly mark on where 1 and 9 is. So 1 is going to be approximately there, 9 is going to be there on the x-axis. This is an x squared with a positive x squared, so it's going to make a u shape rather than an upside down u. But look out for that in this question in particular. It's really important to get the shape correct. So our parabola would go something like this, right? Through the two root points to be something like that. Now, why do we use the graph? What do we need to do on the graph? Well, this is saying our quadratic, our function, our parabola has to be greater than 0. Greater than 0, positive, means a part of the graph above the x-axis. In other words, this part of the graph here, this part of the graph here, remember that carries on forever, but not this part of the graph here, because that part is below 0, less than 0. That would be the part we would look at if it was the other way around. This point, remember, was at 9, this point was at 1, so we want all the part of the graph which is to the right of 9, and all the part of the graph which is to the left of 1. Capturing that mathematically, that would say all the x values that are greater than 9, and this part would say all the x values that are less than 1. And those are the solutions to the question. These questions should be worded not find the value of x, but find the range of values of x. These are the two ranges that they're referring to in the question. If this had been the other way around, if it had been set less than 0, we would be focusing on this part of the graph. If it's this part of the graph which is continuous, whereas these two parts are discontinuous, in other words, there's a gap between them, if it had been that part, you could set up your final answer like this, where it would just need one range of values, and it would be all the values between 1 and 9, so it would be like that. So if it's going to be two parts, probably just separate them. If it's going to be one continuous part in the middle, you could write it like that. But that's how you go about solving a quadratic inequation. Where do these come from? Well, many sources, but particularly from the discriminant. If you get a discriminant question, b squared minus 4ac, and they tell you that it's got no real roots or 2 real roots, then that's going to be either greater than or less than 0. So that would end up giving you potentially a quadratic expression greater than or less than 0. That's quite often the source of a quadratic inequation question.